I'm Sam Manternach. I'm a product engineer here at the Foundry 4.0 Center. I primarily work with robotics, so I do both of our robotic finishing cells, so working with thermal cutoff and mechanical finishing. Do a lot of other side projects involving some 3D printing, and also we do some work, more generic robot code using things like ROS to build custom applications for the foundry industry. I'm a mechanical engineer. I actually graduated from Iowa State mechanical engineering. I've done a couple jobs outside of that, more industrial engineering, and then also a little bit into design. But both of those times I actually involved working around robotic cells. So when I basically heard about the opportunity for here and some of the cool people I'd be working with, basically decided I have the skill set, I can actually slot into this pretty well. And I was actually really drawn here due to its approach of applied research over things of more general research, which I thought I'd have a better grasp at. I kind of like all the brand new challenges, so it's kind of a little bit of a different thing. We get projects from people outside of our little sphere, so kind of like that constantly changing environment, and also getting thrown at new problems, getting thrown at different applications. It's definitely a little bit more different than what I was used to in industry. You don't get to see things quite as thoroughly through as you would out in the industry, but you get to get a helping hand and you get to see a lot more of what's out there and what's possible. We do a lot of work to basically help provide a bridge to smaller companies, or I guess smaller foundries, to get into things like robotics. So I do a lot of things with robotic finishing, which is a big demand in a lot of small foundries. Finishing is an expensive part of the job. It's a part that's really hard to recruit people for and retain people. It's just a very taxing job. So a lot of them are working to try and get some sort of automation in their finishing departments, but it's really hard to do when they work with such small quantities of parts. So a lot of what I will do is try and justify it on those smaller scales, and then try and give them more solutions towards, being able to do a smaller volume. And beyond that, working to build just automated solutions for tasks that, say, take a long time or are really physically taxing for somebody in the foundry. Yeah, I work with a few students. I work mostly with them helping me to do robot programming, and also some more generic programming. So I'll work with students who are in computer science. They have a little bit more skill in actual programming, so they'll be working more, how do I take my inputs off this robot and then convert that into my program, or how's my program going to run off these inputs? And then I'll have students who are more into, say, industrial technology or automation, where they're working more, how is the grinding pad going to hit this part, or what operations are we going to perform to get to the right finishing right part that we like. A lot of these students, they work with small little robots in their classes, and they'll do simple robotic programming tasks. Here they get to pull in a lot of data they'll use in the industry, so they're pulling in new inputs, they're making custom programs for, say, small variations. They're getting to use those skills a lot more. I'm assisting some local foundries, trying to spec out robots for their production line that they're working on. Just trying to be a bridge there of, what things can robots actually do, and, in what environment will it be used. Beyond that, working to do more generic robot code. So we're working with the Steel Founder Society to work on projects to make those generic robot programming, and then to also build the skill set into students who are here already. We send a lot of students out into industry all the time, and some of our hope is we'll be developing those skills to make those new applications, and some of these students are actually just going to end up in foundries building those applications for somebody who's really going to get into automation. If you guys want to learn more about what we do here, we have a lot of great resources on our website, mcc.uni.edu. Lots of really interesting projects we've worked on in the past, and some of the other research we're doing into not only automation and working with those parts of the process, but also working on the science of other things further down the line. A lot of the stuff we do here is working to integrate a lot of sensor data, a lot of process data, and feed it back so we can constantly improve our systems. And I'm working automation and finishing where the rubber really hits the road, but I can also work back to help us figure out everything we do further back down the chain.